This is the equipment that you would use in Chem Inquiry number 1. On the left, there is a bottle of ethanol. It's not normally yellow, but it's dyed yellow so we can see it. And next we've got a bottle of acetone, which is dyed blue. And then the third experiment is going to be with deionized water, which also doesn't normally have any color, but we're going to later add some red food coloring to it so that we can see it, but I didn't add that yet. Next is the small 25 milliliter Erlenmeyer flask, and that's going to serve as the liquid reservoir, and we're going to put into that this tube that has markings on it. It's called a pipette, and we'll look more closely at that later, but that's going to fill with a fluid, either ethanol, acetone, or deionized water, and as we vary the temperature, we'll watch how the fluid moves up and down inside that tube. That's going to sit on top of here like that. All right, we'll come back to that. The next thing is this little red pill here. This is actually a tiny little magnet, and this hot plate / stir bar has the capability, if I turn this knob, you can see that little magnet. It's coated in Teflon, so it slides easily. We're going to use that by putting it inside the little Erlenmeyer flask. And so when that sits on here, set it up just right. When it spins, it's able to actually mix the liquid inside so that the temperature is evenly distributed throughout the sample. We're going to be measuring the temperature using this thermometer that is sort of hanging from a clamp here on a ring stand. So that's just going to hang down. We're not going to stick the thermometer into the little Erlenmeyer flask, because you're going to see that's going to be filled with liquid and it's going to be sealed with this tube on top. Instead, what's going to happen is we're going to make what's called a water bath. And so here's just some regular tap water. And what will happen is we will measure the temperature here of the water bath. And then, once our Erlenmeyer gets filled with liquid and the cap gets put on, we're going to lower that into this bath. And it'll sink to the bottom because it'll have liquid in it. But what we do then is we're going to measure the level of the liquid on the pipette using the numbers on there, and also the temperature at which we make the measurement. And if we let it sit for a while, the temperature of the liquid inside the Erlenmeyer flask, the triangular flask there, will be the same as the temperature of the water bath on the outside. So if we're patient, we don't have to measure the temperature directly inside the little triangular Erlenmeyer flask. We can measure the temperature in the bath. And then the experiment involves basically making changes to that temperature and seeing how that affects the volume inside that tube. And we're going to change the temperature just by adding some ice and then letting it come to thermal equilibrium again. And once everything is settled down, we'll take another measurement. We just do that over and over and over again. And so the idea is that normally each student pair would only do one of the 3 liquids there that we have. We're going to go through and show measurements for all 3 so that you can record the data. So now the next step is to fill this little flask with one of the fluids. And I'm going to start out and use acetone. So the idea, we're going to fill it all the way up to the top without any air bubbles once we put the stopper back in. And so I've already added the little magnetic stir bar. Fill it to overflowing. And you'll notice that I've got some liquid inside the flask now, and it's also filled up into the pipette. And so we're going to take that back. This is ready to use. Now we're going to take this and dunk it into the water bath, and we're going to be ready to take measurements. So we're ready to collect data. The apparatus is all set up. You can see we've got our Erlenmeyer flask that is filled with acetone, and some of the acetone has gone up into the little pipette with the markings on it, and it's sitting in a water bath. And we're going to be able to read the temperature of that water bath. That's one of your data points to collect. And the other data point is to collect the height of the acetone or whatever the liquid is in the tube at every temperature. We're going to change the temperature of the water bath again by adding ice incrementally. So let's zoom in and see what our temperature and the volume of the liquid is in milliliters in the tube. So if we zoom in on the temperature, so you should be able to read that temperature. Look at the markings on the thermometer. So remember, the rule is to read whatever instrument you're using out to 1 decimal place past the smallest marking. So if you look at that thermometer, the big graduations are like 20 and 30. The smaller graduations are each marked off as 1 degree centigrade. And so that your objective is to read out to the tenths place. So if we looked at this one, we would read something like 20.0. Have to include that 0 after the decimal because it tells us the precision. So, this should be 21.0 degrees Celsius. All right, so let's go up and take a look at what's in the tube. And here again, you're going to read the bottom of the meniscus. And let's take a look at the markings on the pipette. And so we can see that the big marked lines represent tenths of a milliliter. So what you're looking at there is 1.8, and it goes up to 1.9 milliliters. And so that means that the small markings in between those are hundredths of a milliliter. So it goes 1.81, 1.82, 1.83, and so on. So because it's marked off in the hundredths of a milliliter, it's marked to the second decimal place. Your objective is to record or estimate this data to the third decimal place. To the thousandths of a milliliter, you should be able to record this data. And so if we take a look at this first one, I want to read the bottom of the meniscus. That's the bottom of that sort of curved half-moon shaped thing at the very top of the liquid. And so if I look at the bottom of that meniscus and read over to the scale on the right, I would estimate that that is 1.865 milliliters. So hopefully you can see that. The bottom of the meniscus is in between the 600ths and 700ths graduation on the side of the scale. And so I'm estimating it's about halfway in between, so 1.865 milliliters. So we've got our first pair of data. We have the temperature that we read, and then we have this volume data. So what's going to happen next is going to add some ice to the water bath. Try not to destroy my setup. But watch what happens to the level of water as this thing cools down. Or the level of acetone, I should say. You can see as the water bath gets colder, the volume of the acetone inside the tube is getting smaller. So you should think about why that would be. There's no air inside. If we zoom back out, we see that there is no air inside. It's just the temperature of the water bath is expanding or contracting the actual volume of the liquid as the temperature changes. So that's called the volume expansion with temperature. And so what we need to do is just keep an eye on this, and we're going to wait until the volume stops changing. When the volume has stopped changing, we know that the volume of the acetone inside the flask is at the same temperature of the water in the bath. And here you can see that the temperature is actually gone down quite a bit from where we started the first time. So we're going to pause this and we'll come back when this thing has gotten to a stable temperature. All right, here's the second data point. Record the temperature and the volume in the tube. Here is data point number 3. Record the temperature and the volume in the tube. Remember, the temperature must be measured up to the 10th of a degree Celsius. And if it's exactly on the line, you would write 0.0. And the volume in the tube has to be measured out to 3 decimal places. So this is data point number 4. Record the temperature and the volume. So this is the last data point. Record the temperature and volume for data point number 5 for acetone. So this part isn't actually part of the lab per se, but I want you to think about what kind of device we've actually built here in this experiment and what we're really kind of doing. You'll notice that the acetone in the tube is going to expand or contract with temperature. In fact, that's exactly what's going on in the thermometer that is on the left, the red liquid. So as it sits in the water bath, it's got a bulb down at the bottom that contains a reservoir of all the liquid inside there. It happens to be a type of alcohol. And as the surrounding liquid or air, whatever it happens to be, around the thermometer changes temperature, then the liquid inside the thermometer expands and contracts. And so what I've done here right now is on the hot plate, I've just turned the heat on. But notice the similarity. We've got 2 reservoirs of a fluid and a long skinny tube that's graduated, upon which we can mark the rising and falling of the liquid in that tube. And so you can kind of just watch in real time, pretty slow, but the temperature is going up because we're adding heat through the hot plate, and both the thermometer liquid and the acetone is going up. So one thing you want to think about is, you'll notice the temperature change is only a few degrees. And so the red liquid in the thermometer is changing really not that much. It's not expanding very much with every temperature change in degrees Celsius. But the acetone, you can see that traveling a lot more up the tube. So for every degree Celsius of temperature change, it looks like acetone expands a lot more than does the alcohol that's inside the thermometer. So really, what we've constructed here is an acetone thermometer. And you kind of have calibration points. If you could take every volume that you marked off on the acetone tube and remark that with a temperature that you read from the thermometer, which you hope is accurate, you could actually create a thermometer out of acetone. Now, I want you to think about, why don't we use acetone like this in a thermometer? Think about how tall that thermometer would have to be just to measure a few degrees Celsius temperature change. All right, that's the end of the data collection. We're going to provide for you the data we collected in exactly the same way for ethanol and deionized water. And you should now move on to using those 3 data sets and doing the data analysis.